Okay, so I want to explain this just a little more. When it says hypotonic, I said water is moving into a cell. Well, when we talk about these solutions or osmotic solutions or states, we're in anatomy, when we talk about them in anatomy and physiology, we're talking about them in relation to the body's osmotic pressure. And when we talk about hypotonic, then that's going to have more water on the outside of the cell um, and less solutes on the outside of the cell. Hypertonic is going to have more solutes um, and less water on the outside of the cell. And when we talk about them being isotonic, they're going to be in equal concentrations. So that means that water is going to move in and out at equal rates. Okay, that means that there's not going to be any net movement of water, but there's still going to be, for every like one molecule that moves water that moves into the cell, another one's going to move out. Okay, so let's talk about this worksheet. Okay, so it wants you to draw an arrow to show which way the water would move by osmosis, and it would fill in any missing percentages, water, solute, and then identify the type of solution, isotonic, hypertonic, or hypotonic. So once you identify the solution that this cell is sitting in, okay? So like we said, water is going to move from an area of high concentration to low concentration, or I said it's going to move from an area of low solute to, or it's going to move towards the higher solute concentration, just because, naturally that works itself out. If there's more solute, then there's automatically going to be less water, or vice versa. So let me see if I can get my drawing tool out here. Okay, and so we see we have high water here, low water here, or this one's lower than the inside of the cell, so water is going to move outwards. Okay, and when water moves out, this is going to be hypertonic solution. Okay, now let's talk about the next one, because we've done everything we can do here because there aren't any missing percentages. This one says 40% water here, 90% water here, okay? So the higher water concentration is on the outside of the cell. Now, if you look, I also said that water moves towards a higher solute concentration. We have 10% solute here, 60% solute here. So it's moving in this, the same. It's going to be moving inward, okay? And we call this a hypotonic solution, okay? And a good way to remember this is, and I'm not putting hypo because it's really hard to draw with this drawing tool, but it's, in hypo, it's fine with me on the assignment, just, whatever you want to do. But a good way to remember hypotonic is water moves into the cell and makes the cell swell up big like a hippopotamus. Hippo, okay, because it kind of sounds similar. Hippo. I'm going to move on down here and show you what an isotonic solution looks like, if it'll let me. Okay, so here we have an isotonic solution. We have 50% water on the inside with 50% solute. Same here, okay? So water is going to be moving in and out at equal rates, and that means that there is not going to be any net movement. Like I said, one molecule of water is going to move in, one molecule of water is going to move out. When we talk about net movement, that means that, like 20 molecules of water moved out, one molecule of water moved in. There's a net movement of 19 molecules that moved out. and this is an isotonic solution. And I actually don't like this example because it could be misleading, so I'm going to find another one. Okay, here's a great one. Okay, here's 90% in, 90% on the out, 10% on the in, 10% on the out. Okay, this is still an isotonic solution. It doesn't have to be 50-50, 50-50. Okay, the same concentration that's on the inside is also on the outside. And this is isotonic. Okay, here we are talking about missing percentages, and these are out of 100. Okay, so if there's 90% solute, then that means there's, or 10% solute, then that means there's going to be 90% water. And if there's 20% solute, then there's going to be 80% water. Okay, now we look and we see, okay, there's 90% water here, 80% water here. Water is going to move from an area of high to low concentration. It's moving outwards. That's hypertonic.